something amazing is happening. Something that will impact the lives of more people in more places than almost anything that has ever come before. It's called the connection effect. The exponential impact of connecting billions of people, tens of billions of things, and representing a transformation that will change our world as profoundly as the Industrial Revolution. A transformation that is quickly evolving from hype to reality. From the farm to the freeway to the factory and a billion points in between. All in the interest of adding value to those new connections where they matter most, our lives. That's the connection effect. And it's happening right now.
Ladies and gentlemen, please welcome Vice President and General Manager, Internet of Things at Intel, Jonathan Ballon.
All right. Welcome to Barcelona. It's fantastic to be invited back again. When I was here last year at the inaugural IoT Solutions World Congress, I encouraged people to believe the hype. Because at the time, the numbers we were looking at were extraordinary, and it was kind of hard to wrap our heads around it. And it wasn't just that I encouraged you to believe the hype because the momentum in the industry was moving, but also I encouraged people to get started and to start experimenting with the technology and engaging an ecosystem of partners to help you do so. So it's been a year, and I thought what we would do today is really reflect back. What's happened? What's changed over the last 12 months? And see, is it in fact accelerating as it certainly feels like it is? And so we'll look at some metrics and we'll look at some examples of how the industry has actually moved in the last year. And hopefully we'll do that again next year and the year after, and this will be our thing. So it's, I think, appropriate that we're in Barcelona for IoT. Barcelona is one of the smartest cities on the planet. The light posts have sensors in them that enable the city to understand crowds and pollution, traffic and noise. They also have sensors in the trash cans that allow them to only have to empty them when they're full. And they've actually re-instrumented their entire bus network so that they've made the city a more efficient grid for public transportation, and ridership is up 30%. You know, it's almost like the city infrastructure itself is now married with this digital grid. And we shouldn't be surprised that these physical worlds are now merging with the digital world, because it was predicted over 20 years ago by this guy, Eric Schmidt, who I think most of us know him as the chairman and former CEO of Google, but at the time, in 1993, he was the chief technology officer of Sun Microsystems, and he said famously at the time that when the network becomes as fast as the processor, the computer hollows out and spreads across the network, or to use their marketing expression, the network is the computer. And you know, Eric actually revised this idea just last year at the World Economic Forum when he said the internet will disappear. And what he means by that is that the internet we know now, today, is the one that we lean into and access through our mobile devices, our PCs, etc. But the future internet is the one that will be invisible. It will be a set of services and applications that run in the background and blend the physical and digital worlds. So I think this is an interesting prophecy, and one that's certainly coming true. We're going to talk about a little bit more later about how I think some fallacies have emerged that are quickly being corrected to go back to Eric's original vision. So last year, I talked about the mountain of opportunity, and I kind of laid out 3 steps that companies can take on the path to employing IoT solutions. It starts with just getting access to the data that you already have, connecting the unconnected, and pulling data off of existing infrastructure so that you can reason over it and derive some benefit and outcome. Secondly is then looking not just at a single machine, but looking at a system of systems or a fleet of devices and getting towards an intelligent system of interconnected things. And then, of course, you know, the grand idea are software-defined autonomous machines. And the best example there, of course, is what's happening at a remarkable pace with autonomous driving. And we just saw last week that Elon Musk announced that all new Teslas, Model S, Model X, Model 3, coming off the assembly line, are all going to be level 4 and possibly level 5 autonomous enabled. This is just amazing. Can you imagine? 4 years ago, we had no idea that this was happening. And now it's not just Tesla. Every major auto manufacturer by the year 2021 will be deploying level 4 autonomous driving capabilities. It's going to fundamentally transform the physical environment that we live in. It will reduce pollution, it will make our streets safer, and it's going to change the dynamic of vehicle ownership. I mean, if you think about it, almost everyone owns at least one car, and you drive it about an hour a day. And it's just 2,000 pounds of metal and rubber that's just sitting wasted when we could have a more efficient application of this technology. We can require less parking spots, reduce CO2 emissions. I'm excited about this future. But over the last year, we've also learned some other things. You know, as companies climb this mountain, there's value creation, of course, and a proliferation of connected devices. And machine data, as I said before, is going to dwarf the human data 22 times the mobile data traffic over the next several years. And of course, as we saw last week, especially, I'm sure you've heard it if you're in the US, and several of the presenters today have talked about it, security is front and center. So let's take a minute to talk about what happened last week, in case you didn't see it. But last week, there was an attack called Mirai that took down a major ISP called DIN. And quite simply, the largest attack in the history of the internet, took down major websites like Twitter, Amazon, Netflix, Spotify, and slowed down many others. I mean, if you see the map of the United States and you see the areas of outages, it's pretty extraordinary. But it turns out, while the attack was sophisticated and well orchestrated, it actually wasn't very technically sophisticated, because it wasn't technical vulnerabilities that were exploited. It was actually default usernames and passwords. Because most devices, when they're shipped, they come with a standard, you know, instruction set, which is, you know, log in using admin and type in password admin, and then change the password, you know, to something secure. And it's that last piece of instructions that people just don't do because they're afraid they're going to forget the password. So all of these devices that were hacked were basically using their default username and password. So we shouldn't be surprised. But the good news is that we're building in, at a hardware level, security that during the provisioning process will make default usernames and passwords completely unnecessary. So security for identity and data storage, in combination with onboarding services, we can completely eliminate the vulnerability. And we're also embedding security below the operating system at a silicon level, which makes it very difficult to compromise. And establishing enhanced privacy ID, which allows authentication of devices when they're transmitting data to be secure before they will release that. So there's a lot of things that are going on. And it's really incumbent upon the industry to start employing as a standard, not just a best practice, but as a standard, security development lifecycle practices from product development all the way through to delivery for the provisioning of devices, for the operation of devices, and the decommissioning of devices. And that's something that Intel customers are asking us to do, and of course we're doing it. But security is something that takes an ecosystem. The entire industry needs to come together around this. Okay, so I said we were going to take a look back over the last year at some metrics. And I thought, instead of just looking at how has the technology evolved over the year, let's look at how the economics of IoT have evolved and some people metrics. All right, let's dive in first with some technology. So take a look at this chart and watch what happens over the last 15 years as connectivity options have emerged in wireless. It's tremendous what's taken place in terms of data rates, range, and power. And today, the landscape is rich with options for virtually any connectivity use case to meet application requirements. But it doesn't stop here, because we now have the promise of 5G on the horizon, which for the first time will be a common set of standards to bring everything from a low-power, low-data transmitting thermostat all the way up to an automobile, which is going to transmit huge amounts of data in real time, and everything in between, all on a common standard across many distances and data rates. And just to give you an idea, if you're unfamiliar with what 5G is going to offer, it's data rates of up to a gigabit per second simultaneously across an entire office floor. It also includes the ability for hundreds of thousands of devices to be connected to the same network in a wireless mesh. And the latency, which is hugely important for industrial IoT cases, is dramatically reduced over current LTE. This is a groundbreaking technology, and it's just one measure. Here's another thing I like to look at, which is Gartner's technology adoption lifecycle. And so you can squint your eyes and try and see how things are moving through this chart. But here's the thing. In Silicon Valley, we always overestimate how long it will take for a technology to become mature and cross the chasm. But we always underestimate just how impactful the technology will be. I mean, look at some examples recently, just the PC, the internet, and mobile phones. They have far exceeded our expectations in terms of their human productivity impact, their societal impact, how they're impacting every industry. And I think we all agree that's why we're here. The Internet of Things will do the same thing. And if you think back only a few years ago, we didn't even have the ability to identify all of these devices. It wasn't until IPv6, which, if you don't know, IPv6 allows 2 to the power of 128 different IP addresses. And that's a number so big, I don't think we even have language to describe it other than scientific notation. And why I think this is interesting is because of that fallacy that I was telling you about, going back to the Eric Schmidt comment. The fallacy that's been pervasive over the last couple of years is that all of the value is going into the cloud, and that everything's all about cloud computing, and all the analytics are going to take place there, and that the edge is just a dumb data source. And that's just not true. Rich, intelligent machines are going to be doing real-time data processing at the edge. I mean, the biggest profound example of this is, of course, of cars. And cars are becoming mobile data centers with hundreds of millions of lines of code, more code than the Hadron Collider or your operating system on your computer. Whether it's a car or it's a digital camera that's processing real-time computer vision algorithms, compute and software at the edge is what it's all about, because you can't move workloads all into the cloud and expect that everything is going to take place there. Some things are going to happen on the device, some things are going to happen at the edge of the network in a fog computing context, and some things are going to happen in the cloud. And it entirely depends on the use case and the economics of moving the workloads and the data and the algorithms, et cetera. But we need to start thinking about things in terms of an end-to-end architecture and not in terms of one or the other. And I think largely, big companies have woken up and are realizing this. So let's take a look at an economic measure. here is a look at some of the M&A that's taken place over the last year. Intel's been busy. As you can see, we've picked up field programmable gate arrays. We've picked up some computer vision capabilities, image signal processing, fantastic collection of assets. But we're not alone. I mean, check out the activity that's taken place this year. It's amazing. I mean, first, NXP bought Freescale, and then we just heard that Qualcomm's buying NXP. Cisco bought Jasper. ARM bought Apical, and then SoftBank bought ARM. I mean, there's a tremendous amount of consolidation that's going on. It's not just happening at the silicon level. It's happening at software platforms and communications as well, because people realize that in order to drive scale and relevance, you need deep capabilities and you need platforms. And that's what's happening, but it's not just limited to M&A. Look at what's happening in the VC community. In the first half of this year, there were over 200 publicly financed VC transactions, over $2 billion. And it's not just the venture community that's investing. Companies are investing. I mean, we know that GE has said that they've invested well over $1 billion in Predix, and they're investing over $500 million a year in software applications. That's just one company. Imagine all of the investments that's going into IoT. It is real. We've also seen a growth in standards participation, not the number of standards bodies, but the number of companies that are participating in developing standards so that we have scalable, secure, resilient solutions that can be deployed en masse. So we're seeing an increase in the number of companies in the standard bodies, as well as the number of companies per consortium. And I don't think in my technology career of 25 years I've ever seen this concentrated and collected effort to develop standards. The developers are also increasing dramatically. Just last year, there were 3.5 million IoT developers. That number is going to double in the next 3 years. These are the people that are building solutions. They're hardening platforms. They're pushing to standardize solution development. And what do they build on? They build on platforms. So today, Intel is announcing the launch of the first truly purpose-built multi-segment silicon platform. It's called the E3900. And let's take a look at what it can do.
The next wave of IoT will connect millions of devices across the globe and make homes, factories, and cities smarter and more efficient. It will protect us on the road and at work, unlock insights and opportunities, and engage people in new and exciting ways. Next-generation IoT technology will change the way businesses operate and how people see the world. Intel is advancing the next era of IoT development with the powerful new Intel Atom processor, exceptional intelligence at the edge, and a feature set designed for tomorrow's IoT systems and applications. The new Intel Atom processor helps automakers simplify designs and deliver stunning in-vehicle experiences. It enables IP cameras and network video recorders to find and identify objects. With Intel image processing, devices can track people and deliver reports in real time. Machines can see their own products as they're being made for instant quality control. The new Intel time-coordinated computing technology can synchronize systems of devices to within a microsecond. The new Intel Atom processor is part of the scalable Intel IoT platform, which helps our customers improve development efficiencies, reduce costs, and speed IoT innovation. Intelligence at the edge delivers bottom-line results. With the new Intel Atom processor, intelligence has never been more attainable.
So we're introducing the E3900 series Atom processor. This is a very exciting platform for us, of course, but what's amazing is that it's also hugely popular with our customers and partners who, over the past year, we've given early access to, and the types of applications that they're building on this platform are amazing. it's already, even though we're only launching it today, it's already the single most successful IoT platform in our history. In fact, at this point, it is 5 times more successful than any prior platform that we've launched. So we're super excited about it. And one customer that's already been innovating is a company called Hikvision. Hikvision makes cameras that are used in smart city applications. This one is used for community security. It's also used in traffic management applications and parking solutions. And what's amazing about this is that historically, cameras were analog. Now, with digital IP cameras, you have the ability to perform rich computer vision algorithms and analytics on the device itself in real time. And with time-coordinated computing, as you saw, not only can you synchronize a set of robots working in a manufacturing line within 1 nanosecond, but you can also coordinate across camera devices so that you can track cars as they move through a city. So it's very exciting. There's lots of use cases for this, and I'm sure you'll be seeing a lot more come out over the coming days and weeks. It also has better security, as we talked about, a hugely important function. This chip has an enhanced trusted execution engine that prevents firmware and OS tampering and provides additional cryptography support for secure data to help prevent any future IoT breaches. It's got almost double the performance of prior silicon platforms and almost 3 times the graphics. And with the imaging processing, it's programmable so that customers can choose to customize it as they choose. So that is the E3900. If you were here last year, you saw this graphic. I love this image. I love it because Bosch is a great customer of ours that also makes digital cameras, but also I just love the majesty of the Golden Gate Bridge and the awesome perspective that cameras like this have and their ability to make our communities safer and more efficient. But it's closer to the ground now in terms of streetlights that are playing an increasing role in smart city deployments. And one of our partners, GE, and their current division is doing a really interesting set of capabilities and using a light post as a platform, not just for delivering intelligent and efficient lighting, but also to deploy a whole set of city services in that lighting platform. Let's take a look at that.
Streetlights represent one of the most pervasive places to put up digital technology in any city. If you imagine, they're pretty equidistant across the city. You have a lot of places to get information. So what GE's done in partnership with Intel is created these Evolve sensors that have ways to see, to feel, to hear, to smell across the city. And what's really powerful about them is using the Intel Atom processors, we actually create metadata out of those. So instead of sharing all the raw data with everyone, which would be too hard to do and cause a number of issues, we create the metadata right on those devices and send that data. With the evolution of the new Apollo Lake platform, the amount of processing we'll be able to do on the edge, the number of algorithms we can run in parallel will increase to create even more opportunities. So we're excited to be building that into our roadmap moving forward. We can show you a few examples of that here. Let's think about things like how people move through a city. Here you can see an example of the Evolve systems looking at, through their cameras, the people that are moving through the cities. But what you're not seeing is you're not seeing personal information about people, you're seeing metadata. How many people? What direction are they moving? What count is it that we have overall in the space? So that information can be used to figure out how is traffic flowing, how are people adjusting their way through the cities. For any of us who have ever tried to drive through a city, we know parking can always be a tremendously difficult opportunity. What we look here is finding sensors that are looking and finding available parking spaces when someone's moved in, when they've moved out, how much time there is. That can help all of us as we move through the cities. It can help cities do things like parking enforcement, but it provides the foundational metadata to understand what's happening for a city in terms of parking. Another example would be to look at how vehicles move through the city. Being able to detect the difference between cars and trucks, what speed are they moving, what direction are they moving, helps us get a really good indication as to how congestion moves in the city. And these Evolve sensors do much more than just look at things and use cameras to find metadata. They're also being able to be extended into other types of sensors, like environmental sensors, where we can see air quality and a very detailed view of what type of pollution and things that are in the air so that we can get a detailed map of a city and start to find sources, causes, and figure out ways that we can make that work better. I'm very proud of what GE does. I'm very proud of what Intel has done. What I'm most excited about is that when we work together, it doesn't make us better, it makes all the people around us better. So when you have students and entrepreneurs and others who are now able to take on solutions that before they had in their brains they just couldn't make real, this is when we actually make transformation and make things happen in the real world, and that's what I'm really excited about.
So what John was talking about at the end there was that what we're doing is opening up the APIs of this platform to the developer community and to schools so that we can stimulate innovation and allow people to write applications on the data that's coming off of these streetlights to help improve our communities. And I think that's a very exciting innovation. But the IoT reality doesn't end with this keynote. If you make your way over to the Intel booth at some point during the show, you're going to see a lot of examples. In fact, another example from GE that we have in the Intel booth is the Rail Connect solution from GE, which is a Predix-optimized locomotive that's driving tremendous amounts of innovation in the transportation industry. Also in transportation, we have a fleet tracking system that we developed with Accenture. And if you're interested in smart cities, there's a Wind River demo, there's a Bosch demo. We also have a smart building demonstration with Amazon Web Services. And from an industrial point of view, smart industry solutions from IBM and Siemens. And of course, running the new E3900 Atom processor is a platform by AdLink, which is the SEMA Cloud Industrial IoT platform, which allows for device attestation and management across a distributed architecture. It's a very interesting platform. I highly recommend you take a look at that. And last but not least, over the last couple of days, we've had a hackathon. It was actually the first IoT hackathon on the Intel Joule platform. And we had 3 winners. Many teams competed. They slept in sleeping bags like on the concrete in this convention center for the last couple of nights. We have 3 great winners chosen, and they are showcased in the Intel booth as well. So please take a look and have an amazing show. Thank you very much.